Ever felt just completely overwhelmed when you're like trying to manage a ton of storage drives?
Yeah, it can be a lot.
You're not alone.
Definitely not.
But what if you had like this secret language, right? To like talk to all the drives and get information from them and even like tell them what to do.
Give them commands.
That's exactly what we're diving into today.
It is.
The NVM Express Management Interface.
Or NVMe.
Revision 1.2.
That's right.
Sounds pretty complex.
Well, think of it this way. You're in a massive data center, right?
Okay, yeah.
Rows and rows of those super fast NVMe drives.
Okay.
NVMe is like the key to keeping all those drives running smoothly,
Huh?
even remotely.
Really? Okay.
So we're going to be decoding diagrams and tables today.
Wow.
Even some code snippets
Oh, fun.
to understand how it all works.
Okay, so we have this like really dense document in front of us.
Yeah.
Before we like get lost in all the technical jargon, can we take a step back?
Sure.
What exactly is NVMe?
NVMe stands for NVM Express Management Interface.
Okay.
And it's essentially a standardized way to manage all those NVMe storage devices,
Okay.
which is especially crucial in, large-scale data centers.
Yeah, for sure.
So imagine being able to, monitor the health of your drives,
Okay.
update the firmware, even securely erase data,
Oh,
all without physically touching them.
that's pretty amazing.
It is.
But how do we actually talk to these drives?
Yes.
Is it like smoke signals or carrier pigeons?
Thankfully not.
Okay, good.
The document actually outlines two primary ways to communicate with these drives.
Okay.
We have out-of-band communication
Okay.
and in-band tunneling.
2 ways, huh?
2 ways.
So tell me about out-of-band communication.
Okay, so imagine out-of-band communication as like a dedicated side channel.
Okay.
Almost like a backdoor for management tasks.
Okay.
It uses a special protocol called MCTP,
MCTP.
which can be transmitted over SMBUE SI2C or PCIe. It's like having a separate phone line just for managing the drives.
Gotcha. And what about in-band tunneling?
So in-band tunneling, it kind of sneaks those management commands through the regular NVMe data path
Oh, okay.
using special NVMe admin commands.
Interesting. So it's like using the existing infrastructure then.
Yeah, it's efficient, right? Because it doesn't need a dedicated channel.
Makes sense. So it's more like sending like a coded message like hidden within a regular package.
Exactly.
Okay, so we've got these 2 ways of talking to the drives. I'm sure there are some technical terms we should probably understand
Yeah, sure.
to like really grasp this document.
Yeah, absolutely. Let's start with management endpoints.
Management endpoint.
So this is essentially the point of contact on the storage device, right?
Okay.
Where we send all of our management messages.
Okay.
Think of it as the mailbox for our NVMe MI instructions.
Gotcha. Okay, mailbox noted.
Yeah.
What about these command slots? How do those work?
So each management endpoint has designated slots where incoming commands are placed and then processed, right?
Okay.
So it ensures that everything's handled in an orderly fashion,
Okay.
like a restaurant queue.
Like you get a number, you wait your turn.
You don't want your identified drive command getting mixed up with a format command.
That would be bad.
Right.
Yeah. Okay, what about this FRU information device?
It sounds like a sci-fi gadget,
It does.
but it's simply a digital ID card for each drive.
Okay.
FRU stands for Field Replaceable Unit.
Okay.
The FRU ID contains crucial information about the drive, right?
Okay.
Like its specifications, requirements, all that.
So it's all about like identification and smooth communication.
Yeah.
And you mentioned this VPD thing earlier.
Vital product data.
Vital product data. Okay, that sounds important.
It is. It's part of the FRU ID, right?
Uh-huh.
It's a standardized way of storing all this information about the drive.
Okay.
We're talking model number, serial number, firmware revision, even power consumption details.
Oh, wow. Everything you need to know about that specific drive.
Okay.
You can see why this is so valuable, right?
Yeah, for sure.
Imagine being able to instantly pull up all the critical details for any drive in your data center.
That's a huge time saver.
Right.
It's like having a Google search for your physical hardware.
Exactly.
That's awesome.
Yeah.
So we've established communication, right? We know who we're talking to.
Right.
Time to give them some instructions.
Time to tell them what to do.
What kind of commands can we send using this NVMe?
Okay, so there are some really powerful ones. One of the most basic is identify.
Identify, okay.
It's used to retrieve all sorts of details about the drives.
Right.
Think of it as like getting a comprehensive report on its identity and capabilities.
Okay, that makes sense. What other commands can we use?
So we have get log page.
Get log page, okay.
That allows us to peek into a drive's internal logbook.
Okay.
This log contains information about the drive's, performance and health.
We can then analyze those logs to, understand how the drive's performing, identify any potential issues, and even optimize performance.
It's like a health checkup, I guess.
Yeah, and a performance review all in one.
That's pretty cool. Speaking of potential issues, can we wipe a drive clean remotely using NVM EMI?
Absolutely. The sanitize command.
Sanitize, okay.
It ensures data security
Okay.
by completely wiping the drive.
Oh, wow.
Making it impossible to recover any sensitive information.
Okay.
So it's crucial for data centers that are, decommissioning drives or repurposing them.
That makes sense. What about prepping a new drive, like getting it ready to use?
Yeah, so we have the format NVM command,
Where's that big down?
which preps the drive and sets it up with, the correct formatting
Okay.
and structure for use in the system.
That makes sense. And how do we safely power down these drives?
The shutdown command,
Shut down, okay.
it ensures a controlled and safe shutdown, which is important when you're, performing maintenance or upgrades.
Yeah.
You don't want to, abruptly pull the plug, right?
No, definitely not. What about monitoring the drive's health, though? Can we get, alerts or something if there's a problem?
Yeah, so health status poll allows us to periodically check on the drive's well-being.
That's the status poll.
It provides real-time updates on, critical parameters, right?
Okay.
Like temperature, available spare capacity,
Okay.
any warning flags,
So it's like a constant checkup.
Exactly.
Make sure everything's running smoothly.
Huh.
You mentioned earlier that some commands work differently depending on whether we're using out-of-band or in-band communication.
Right.
Can you give us an example?
Sure. Let's take the VPD read command.
Okay.
If we're using the out-of-band method, we can directly access the FRU information device via SMBUSI2C and retrieve that VPD data.
Okay.
But with in-band tunneling, we would use the NVM MI send and NVM MI receive commands to tunnel that VPD read request through the regular NVMe data path.
So it's like a little more roundabout way of doing it.
Yeah, a bit more indirect.
But it still works.
But it works within the existing infrastructure.
That's pretty amazing.
It is.
How much complexity is in these, seemingly simple commands?
Yeah.
Seeing them in action would really help.
Absolutely.
Solidify my understanding.
Let's move on to some real-world examples then.
Okay.
Where we can look at some code snippets and break down, how these NVMe MI commands are actually implemented.
Sounds good.
Yeah.
In practice.
Let's get to the code.
Let's do it.
Now that we've covered those individual drive commands,
Right.
let's zoom out a little.
Okay.
Look at the bigger picture.
Yeah.
What about managing a whole bunch of drives at once?
Yeah.
All the ones you'd find in a data center.
Sure. So that's where NVMe enclosures come in.
NVMe enclosures.
Think of them as high-density apartment complexes for NVMe drives.
Like little houses. Yeah, rows and rows of them.
Gotcha.
Often found in data centers.
Okay.
They provide power, cooling, connectivity
All the essentials.
to a large number of drives.
Makes sense.
But managing all that
Yeah.
could be a real headache.
I can imagine.
Right.
So how does NVMe help with that?
So NVMe MI gives us a standardized way to monitor and control various aspects of the enclosure,
Right.
make sure things are running smoothly.
Okay.
We're talking about monitoring temperatures, fan speeds, power supplies,
Oh, wow.
all remotely.
So instead of physically going to the data center,
Right?
we can monitor everything from somewhere else.
Exactly, from a central location.
That's pretty awesome.
And it's not just monitoring.
Okay.
Imagine a fan fails in an enclosure.
Oh,
With NVM MI, we can get an alert, right?
okay.
Potentially even switch to a backup fan,
Oh, wow.
all remotely.
So it's like a safety net.
This level of control and insight is a lifesaver for those data center administrators.
I bet it is. I remember seeing something about SES commands in the document.
Ah, yes.
Can you explain those?
Sure. So SES stands for SCSI Enclosure Services.
SCSI enclosure services.
It's a separate standard that's been around for a while,
Oh, okay.
used for managing traditional SCSI enclosures.
Gotcha.
Now, you might wonder, Why would we use a SCSI standard for NVMe enclosure?
Yeah, that seems a little strange.
Right, so instead of reinventing the wheel, NVMe MI leverages that well-established SES framework
Okay.
by incorporating those commands.
Clever.
It's all about efficiency and using proven technology
Right,
in a
yes.
new context.
Makes sense. So we're talking about using specific SES commands
Right,
within NVMe.
exactly.
Okay, cool.
So two key SES commands that you'll encounter are SES send and SES receive.
Okay, SES send and SES receive.
Think of it like sending and receiving special instructions or reports.
Okay.
For SES send, we can send control commands to the enclosure,
Right.
like setting fan speeds or retrieving a log, right?
Makes sense.
Then SES receive
Okay.
allows us to get reports back from the enclosure.
Okay, so it's like a two-way conversation.
Yeah, a status update, essentially.
So it sounds like these SES commands give NVMe MI a whole new level of management capability.
Absolutely.
But we talked about, out-of-band and in-band communication for individual drives.
Right.
Does that apply to enclosures too?
That's a great question. So the document specifies that NVMe MI enclosure management
Okay.
is primarily focused on the out-of-band method.
Out-of-band. Yep.
Remember that dedicated side channel we talked about?
Yeah, like the separate phone line?
Exactly.
Okay.
It's ideal for enclosure tasks.
Yeah.
Because we don't want to interfere with the, high-speed data traffic
Right. Kicks up or
flowing through the drives themselves.
makes sense.
Now, with all these commands flying around,
Yeah.
are there mechanisms to make sure things don't get chaotic?
Good question.
Absolutely. Remember those command slots we talked about earlier?
Yeah, the restaurant queue.
Exactly.
Okay.
They act like dedicated queues for all the incoming commands.
Okay.
They process them sequentially.
Gotcha.
Prevents the system from getting overwhelmed.
That's good.
Right.
What about the data itself, though?
Yeah.
Is there, a temporary holding area
Yes.
for all that
Well,
information?
we have the management endpoint buffer,
Management endpoint buffer.
which acts as a temporary storage area
Okay.
for the command data.
Yep.
Think of it like a staging area before a concert,
Okay.
where everything's organized
Right.
before it's sent to the stage.
Okay.
This buffer allows for efficient handling of large data transfers,
Okay.
especially when you're retrieving those detailed logs or
Good idea.
reports from the enclosure.
It's fascinating how much thought goes into making sure this all runs smoothly.
Right. A lot of clever engineering.
The document also mentions specific data structures
Yes.
used in these NVMe MI communications.
Mm-hmm.
Can you explain what those are?
So those data structures are the backbone of the entire system. They define the format of the information exchanged between the management software and the NVMe devices or enclosures. Like a blueprint for how that information is organized and transmitted.
So when we send a command,
Yes.
the response we get back is structured according to a blueprint.
Exactly.
Okay.
This ensures consistency
Right.
and clarity in communication,
Okay.
regardless of the drive model or manufacturer.
Makes sense.
So, for example, when we send that identify command, the response isn't just a jumble of data.
Okay.
It's structured
Okay.
according to the identify controller data structure,
Wow.
which specifies which byte contains, which piece of information about the controller.
Okay.
Like its vendor ID, model number, all that stuff.
That's pretty incredible
It is.
how standardized this all is.
It is like a massive library.
Yeah.
With all the books organized by category and author.
Everything in its place. Now, what about those topology multi-records I saw in the document?
Oh, yes.
Those sounded pretty interesting.
So they provide a way to represent the physical layout and connections within an NVMe enclosure.
Okay.
Think of it as a detailed map of the enclosure's internals, showing how all the components are interconnected.
So we're talking about PCIe switches and drives.
Exactly.
Okay.
Like having X-ray vision into the enclosure's structure.
That's really helpful
Right.
for visualizing how everything's laid out.
It is.
But with all these features and capabilities, NVMe MI must be pretty complex to implement.
Well, the document acknowledges that,
Okay.
it can be challenging.
Is there, a step-by-step guide or something?
So it provides clear guidelines and recommendations
Okay.
to ensure consistency and interoperability across different implementations.
Okay.
While it doesn't offer a step-by-step guide, it outlines various options, right? Allows manufacturers to tailor their implementations to their specific hardware capabilities.
So it's flexible.
Exactly.
for work with all these different devices.
The goal is to establish a common framework
Okay.
that allows for innovation
Okay.
while maintaining interoperability.
That makes sense.
Remember, we're talking about managing potentially thousands of these drives.
Right.
So having a standard like NVMe MI is a game changer.
Yeah, I can see how important that flexibility is, especially with technology constantly evolving.
It is.
Now, amidst all this talk about technical details,
Yeah.
I'm curious about the energy consumption of these systems.
Oh, yes.
Does NVM EMI address power management at all?
Absolutely. Power management is crucial in any data center.
Right.
And NVMe MI incorporates those features for efficient and controlled power consumption.
Okay.
It outlines various power states that NVMe devices and enclosures can transition through.
Okay.
You know, from fully powered on to
Right.
various low power modes, all controllable remotely.
So it's not just about managing the data.
Right.
It's managing the energy, too.
It is.
That's really impressive.
It is. So, for example, imagine a drive that's been idle for a while.
Okay.
We can safely transition it to a low power state.
Okay.
Using NVMI, reduce energy consumption without disrupting operations.
That's smart.
Right. Like different sleep modes for our drives.
Yeah.
Each tailored for a specific scenario.
So are there different power states?
Yes.
For different levels of inactivity?
The specification defines several power states,
Okay.
each with its own power consumption characteristics and wake-up latency.
Okay.
This allows for, fine-grained control
Gotcha.
over power management,
Okay.
balancing those energy savings with performance requirements.
Makes sense.
As data centers continue to grow,
Yeah.
efficient power management becomes even more critical,
Right.
and NVMe MI is equipped to handle that.
That's good. Sounds like we've covered a lot. From individual drive commands to managing entire enclosures
Yeah,
and even power consumption.
it's a lot.
Is there anything else we should know about this NVM MI? Before we move on, we've talked about managing all these drives and enclosures
Yeah,
of in power consumption.
right.
But what about,
Uh-huh.
the elephant in the room,
Okay.
security,
Yeah, it's a big one.
with all this remote access and control?
Right.
How does this NVM MI
Yeah.
make sure our data is safe?
So luckily, the document highlights some pretty robust security features
Okay.
built into that NVMe MI framework.
That's a relief. So can you tell me more about those?
Sure.
What kind of safeguards are we talking about?
One of the most important is authentication.
Okay.
Before any management commands can be executed,
Mhm.
NVMe MI requires proper authentication.
Okay.
It's like having a security guard at the door,
Okay.
checking your credentials before granting access.
So not just anyone can just walk in and start messing with stuff.
Not at all. The specification details various authentication mechanisms,
Okay.
including passwords, security certificates,
Okay.
even hardware-based security features.
That sounds pretty secure.
It is.
But what about the data itself while
Nah.
it's, being transmitted?
Right.
Is there any protection for that?
Yes. NVM MI supports data encryption
Okay.
to safeguard all that sensitive information
Okay.
during those out-of-band and in-band management exchanges. Think of it like scrambling the message, right?
Okay.
So even if someone intercepts it,
Yeah.
they can't read it.
Like sending a secret message in code.
Exactly.
Okay, that makes me feel a lot better.
Good.
What kind of encryption are we talking about?
So the document mentions using industry standard encryption protocol,
Okay.
like TLS-SSL,
Okay.
the same technology that secures, your online banking transactions.
Gotcha. So it's pretty strong encryption.
It is.
Good to know they're not cutting corners.
Right.
Is there anything else to prevent, like, unauthorized access or accidental data breaches?
Yes, the document mentions a feature called Command and Feature Lockdown.
Command and feature lockdown.
This allows for granular control over which commands can be executed
Okay.
and which features are accessible. It's like having a customizable security policy.
Gotcha.
We can lock down specific commands,
Okay.
make them inaccessible even with proper authentication,
Okay.
or restrict access to sensitive features
Okay.
based on, user roles or security clearance.
So like different levels of access for different people.
It adds another layer of protection.
Thinking about all the security implications of this
Yeah.
really highlights how important it is to have,
Right.
a robust and well-designed management framework.
It is. Yeah.
Like this NVM MI.
Absolutely. As data privacy and security concerns grow, NPME MI provides the tools and features to address those.
That's good.
And are.
Well, we've covered a ton of ground today. Explored like all the ins and outs of this NVMe
Hunt the
MI,
intricacies.
from basic commands to advanced stuff.
Yeah, enclosure management, security, all that.
Configuration options. Yeah, it's been a real deep dive.
It
I
has.
feel like I've learned a whole new language.
It's a lot to take in.
It's amazing to see how all these, like, seemingly separate elements,
Yeah.
the data management, security, power management,
Right.
they all come together
They do.
to form this, like, unified interface.
NVMe is really a testament to all those engineers and industry experts who designed this framework for managing these complex storage systems.
It's clear this technology is going to be critical moving forward.
Oh, absolutely.
As data becomes more and more central to our lives.
It is.
Our businesses.
We encourage you to delve even deeper into the aspects of NVMe that, that interest you.
Yeah.
There's a whole world of knowledge out there.
For sure.
Waiting to be discovered.
This deep dive has given me a much greater appreciation for the power and potential of NVMe.
It's powerful stuff.
Thanks for guiding me through it all.
It's been a pleasure. Happy managing.